Let's take a look at a quick example of how the correlation coefficient for a set of sample data works. Scuba divers have maximum dive times that they cannot exceed when going to different depths. The data in the table show different depths with the maximum dive times in minutes. Find and interpret the correlation coefficient R for the data. So we have our X, that's the depth in feet. We have our Y, that's the maximum dive time. We want to find the correlation coefficient. We want to see if this data appears to be linearly correlated. Okay, so I'm going to start by transferring my data to R. So I'm going to have two sets of variables, my depth in feet, X. So I'm going to put the data in here. I have 50, 60, 70, 80, 90, and 100. Those are the different depths in feet that we're looking at. And for Y, I'm going to use the maximum dive time. And I want to make sure I go in the same order, right? Because when you are 50 feet deep, your maximum dive time's 80 minutes, okay? And so you want to make sure these are paired. So staying in the same order lets the computer know that they will go together. Okay, for 60 feet, maximum dive time is 55 minutes. And for 70 feet, it's 45 minutes. For 80 feet, it's 35 minutes. For 90 feet, it's 25 minutes. And for 100 feet, it's 22 minutes. And all I'm going to do is get my correlation coefficient. And for my sample data, I use R for the correlation coefficient. And this is, I'm going to use the function COR, and then X comma Y. That's going to find the correlation coefficient between these two variables. Okay, so let's see what we get. And we get a correlation coefficient of negative 0.962938. Okay, so our correlation coefficient R is negative 0.962938. So what does that tell us? Well, first off, it's negative, right? So the data is going to appear to be negatively correlated. From left to right, we would expect the data to generally trend downhill. So negatively correlated. Perhaps more important is how strong is the correlation. Is this very close to 1 or negative 1? Well, in this case, it's negative, so we're checking if it's very close to negative 1. Negative 0.96, that is very, very close to negative 1, right? Much closer to negative 1 than it is to 0. So because R is very close to negative 1, we expect the data to be strongly correlated. Okay. We kind of visually confirm this by doing a quick scatter plot of our data. Let's see what the scatter plot looks like and see if our intuition of how strong that correlation is matches what it looks like in the scatter plot. Okay, so I'm going to go plot, and I just plug in my values, X and Y, my lists of values. That's going to give me a scatter plot. And look at that scatter plot. Let me copy it over here so I can draw on it. Okay, that correlation does appear pretty strong, doesn't it? The data very roughly fall within a straight line. There's not a lot of data points, but they very nearly are a perfect line, right? These ones right here, they look like they fall perfectly on a line. These ones over here are a little wonky, but between them all, it looks like there's a pretty darn strong linear correlation. As X gets bigger, Y is getting smaller, right? As our X's get bigger, as we go this way, our points tend to go down, right? As our minutes, is our depth in feet. As the depth in feet that we're diving increases, the minutes we can stay underwater goes down. Okay? So just looking at that scatter plot intuitively, we're getting that same strength of the correlation that we see more mathematically in finding that correlation coefficient. It is not a perfect line, right? It's not, all the points aren't lying perfectly along the line, but it is a very strong relationship.